Hello everyone. This week we are going to be looking at the topic of similarity, and I'm going to give you a quick rundown of what we're doing this week. I'm going to try and keep this video short, so I will be talking quite fast. First of all, just a quick kind of update on the reason why I want to do this topic. On the survey, direct and inverse proportion came out as second, but because we've only recently done that topic, I want to give ourselves a little bit of a break before we go back and revisit that topic. So I want to look at similarity and congruence, which is one of the topics that you started just before the lockdown. So I want to look at that first. So we're going to do similarity this week, congruence the week after, and then direct and inverse proportion the week after that. Okay, so just what's going to happen this week. So this is the breakdown of your 4 lessons. The first lesson, we're going to look at some simple and some advanced questions on similarity. And that's going to be Monday's lesson. Tuesday's lesson, we'll look at area and volume problems to do with similarity, which can get a bit tricky. And then your third lesson this week, whenever you have it, we'll look at some exam questions related to this topic. And remember, that is the topic that lesson is the one where I want you to submit something. So please make sure you do the exercise and you submit it so I can check that you've done it. And that's your third lesson this week. Mr. Hemming is going to do his exam problems and some Zoom as well. And okay, so let's just talk about this one video. So this lesson, there's only going to be this one video for you to watch. And the exercises that I want you to complete are exercise 29 from page 246 and 30 from page 249 from Caboodle. I do think I have got the page numbers right. I've double checked that. By the way, exercise 30 is the difficult one, and exercise 29 is the easy one. So this is the easy one, and this is the difficult one. And really, it's up to you how much you do, because they are quite long exercises. So, and if you want to go straight to the difficult one, then that's fine. And by the way, if you feel confident with this video and you think, I know this from what Sir or Miss taught me in class, then you might want to just go and do those exercises right now. It's up to you if you feel confident enough with this one video, but let's get into it. Okay, so similarity. What's similarity to do with? Well, okay, in a kind of simplistic way, it's to do with shapes and them being like a bigger or smaller version of each other. So something to do with what we call scale factors. So basically, these two shapes are similar because one version is a bigger version of the other or a smaller version of the other. They've been scaled up or scaled down. But one thing about scale factors that you need to be careful about is sometimes the question will say the word similar or these two shapes are similar, then you know it's to do with scale factors. But in these two triangles here, we're not really given enough information to say that they are similar. I know I've told you that they are, but the one key thing to look for sometimes is that the sides are a multiple of each other. So for example, this side is 8 and this corresponding side is 24. So you can see that the scale factor is 3 because 8 times 3 is 24. So 5 times 3 is 15. So this side would have to be 15. And well, okay, going the other way, this side would have to be 7 because 21 divided by 3 is 7. But another thing to look for in similar shapes is the angles, okay? Because when you make a shape bigger or smaller, the angles do not change, right? Okay, the angles stay exactly the same. And the way to tell someone is that the angles are the same in these two shapes is by kind of drawing arcs in the corner. So what I mean by that is this angle in the left-hand corner is the same as this one. So you draw one arc. This one at the top is the same as this one at the top here. So you draw 2 arcs, say they're the same. And then this one in the corner here, let's just draw 3, is the same as this one down here. So you draw 3 arcs. So that tells someone that this angle matches this angle matches that one, and this one matches that one. And by default, because the angles match each other in both shapes, these two triangles have to be similar, okay? And then there's that scale factor involved in them, okay? Now, let's just talk about that scale factor in a bit more detail now. Okay, so the way I find this scale factor is dead simple. I find two sides that correspond to each other, that effectively are the same side of the triangle on both triangles. So what I mean by that here is, for example, this 8 and this 24 are the ones that correspond to each other. And then once I've found these two sides and I know the length of them, I just take the big one and divide it by the small. And that's your scale factor. So 24 divided by 8 is 3. That's your scale factor. But the scale factor, because I've done the big divided by the small, that's the scale factor to go this way. So everything is multiplied by 3 to go that way. And then the opposite way would be to divide by 3, right? So 5 is on the small triangle, times 3 to get to the big triangle is 15. So that's that side there. And 21 is on the big triangle. So to go the other way, you have to divide by 3. So that would have to be 7. 21 divided by 3 being 7. So that side's got to be 7. So I always do big divided by small. And then that's the scale factor to get from the small one to the large one. And then you do the opposite to kind of go the other way. So times by 3 to go that way, divide by 3 to go that way. And I hope that makes sense. Right, but remember I said to you about angles, because they really do matter, and it's very, very important that you think about the angles when we talk about similarity. Okay, so first of all, these two triangles are similar, but in order to prove that, in order to make sure that they are definitely similar, we need to really consider the angles, and really that gives us a bit of orientation as well. So, okay, one thing about these two triangles that I haven't put in there is that these two sides are parallel to each other. So we've got some parallel line stuff here. So first of all, I'm just going to double check the angles and make sure that they are the same, and that's going to give me a bit of an orientation as to which side corresponds to which one. Okay, so first of all, these two angles are opposite each other, so they're the same. Remember, these two lines are straight lines that cross each other, so the opposite angles are the same. So they're the same. Okay, now this angle here, remember your F angles corresponding in alternate angles. So this angle here has got to match this one over here. So that angle is the same as that one. And this third angle, if you kind of look at this, there's a Z shape going on, so it has to correspond to this one here. So those two angles are the same. Now, the corresponding sides. Okay, this is where it gets a bit tricky. And sometimes it might be a good idea to kind of draw these triangles kind of like the right way round to make sure that you've got the right corresponding sides. Okay, because what some students might do is they'll take the 5.5 and divide it by the 3. But that's not quite right. Okay, the 3 is actually corresponding to 6.6. And the reason for that is if I draw these two triangles kind of like the right way up, and I'm going to do that now. So here I've drawn the angles kind of like on the same side. So you've got the bottom angle, this third one is the third one, the second one's at the top. And if we kind of just fill in the sides, so for example, the 3 centimeters is between the 2 and the 1, so that's 3 there. But the 6 is also between the 2 and the 1, so that's 6 there. So you can see, sorry, 6.6, sorry. So you can see that these two sides are the ones that correspond to each other. If you kind of imagine just rotating these triangles around so they're all kind of like the angles are in the same corners, then this side matches this side. So it's really, really important that you don't get the two sides confused. Okay, so the scale factor. So the scale factor is going to be, I'm just going to abbreviate to SF, is going to be the big divided by the small. And that's equal to 6.6, which is the bigger one, divided by 3. So that's 2.2. Okay, so to get from the small triangle to the big triangle, you have to multiply by 2.2. So to go the other way, you have to divide by 2.2. Now, it's kind of a bit of common sense, really. Because the 3 matches the 6.6, the 5.5 must mark the side that we want. Because it's on the big triangle, you have to just do 5.5 divided by 2.2, and that's going to give us our question marks. So let's just do that now on the calculator. So that's 2.5 centimeters long. That's how long this side is here. Okay, now those two examples are quite straightforward, and really I hope you don't struggle with those. Let's look at some harder questions related to it. Okay, so here's a sort of it's not too difficult, but it's pretty straightforward. Okay, so we have this shape here. We're asked to work out this side here, and some missing information. First of all, these two sides are parallel again. Okay, so how do we work out that side x there? And we're told that this center line is 11 centimeters. From here to here is 15, and from here to here is 6.3. Okay, so first of all, let's just double check the angles. Okay, so, all right, what's the best strategy? Okay, I think the best strategy is probably to do a little sketch of the two triangles that are hidden in this picture. You can see that there's two triangles hidden in this picture that are drawn on top of each other. And actually, I'm going to reveal them to you now. So here they are here. I've just basically drawn this little triangle out here, and then the larger one there. Okay, and I'm just going to fill in some missing information now. So first of all, this angle here, they both share that angle, so this angle's got to be the same on both. Okay, bit of corresponding angle stuff going on now. This corner angle, can you see the F shape, because these two are parallel, has got to be the same down here, so they both have this angle which is the same here. And there's another F kind of like down like this, is kind of like an F shape here, so corresponding angle. So this third angle has got to be the same as this third angle here. So that means that these two triangles are definitely similar to each other, because the angles match each other. And then what I'm going to do is fill in some missing information. So on the pink triangle, that's 15, that's 11. Okay, but this is where students go wrong. Okay, this entire length is actually 15 add 6.3. So this side is 21.3 long. And then this is the side x. Now, when you draw these two triangles out separately, it's actually really easy to work out what the scale factor is. The scale factor is, okay, which two sides correspond to each other? Well, it's obvious, it's the 15 and the 21.3. So I'm going to do the big divided by the small. Okay, I'm going to use my calculator to work that out. So 21.3 divided by 15 is 1.42. Now that's the scale factor. So to get from the big one, from the small one to the big one, you have to multiply by 1.42. Oh, God, I made a right mess there. Hang on. Okay, so to get from the small one to the big one, you multiply by 1.42, and to go back, you have to divide by 1.42. So x is on the big triangle, but it corresponds to 11. So 11 times 1.42 is the calculation we need to do. So if I just do that on the calculator, we get 15.62, which is how long that side has got to be. So it's always a good idea to, if there's two triangles drawn on top of each other, it's always a good idea to draw them out separately like this, and then fill in the missing information. A little sketch would do. It's just easier to see what the scale factor is, because I see sometimes students just do that divided by that, and then they get the wrong scale factor, and then they end up working out x incorrectly. So it's just a good idea to kind of make sure just a visual representation. Okay, let's do another one. Okay, so we're asked to work out side x here. So x is going from here to here, and again it's two triangles drawn on top of each other, and then these two sides are parallel. So now this question's a bit tricky. Okay, this one's not easy. A bit of algebra involved. Now there might be a different way to do it than the way I'm about to show you, and if you get the right answer and you think, you know, the way I've done it is a lot better, then it's fine by me, as long as you get the right answer. Okay, so what I'm going to do first of all is I'm going to draw the two triangles out separately. So this is the one that's got x and 15, and then the larger one, which is kind of like the one that sticks out. Okay, now that's 36. Okay, let's just double check the angles now. This angle is this one, and they both share that one. And because these two lines are parallel, this one, okay, let me draw two, is the top one here, but by corresponding angles, it's got to be the same as that one. And then the bottom one, by corresponding angles, is the same as this one here. Okay, now, this is where the kind of algebraic side comes from. Okay, this side here from, let me pick a different colored pen. So this side from here to here, we don't know how long that side is, but what we can say is this side has got to be x plus 7. So this is x plus 7. Again, we don't know what x is, but if we knew what it was, you just add 7 to it, and that's how long this side is here. And that corresponds to this blue side here. So they match each other. Okay, now the scale factor is easy to work out because we have this 15 and this 36, and they clearly are the corresponding sides. So first of all, I'm going to work out the scale factor, which is 36 divided by 15. Okay, and that's equal to 2.4. Okay, that's the scale factor. Now, this is where the kind of the algebra comes in. Okay, and I hope you understand this. So first of all, any side on the small triangle is going to get multiplied by 2.4, and that will give you the length of the side on the bigger triangle, right? Okay, because remember on these ones here, for example, this one here, on the small triangle you times by 3 to get the big one, and you divide by 3 to go back. Well, we're kind of using that logic here. So this small triangle, any side on the small triangle, if you multiply it by 2.4, that's got to equal the same side on the bigger triangle. Okay, now this is where the maths comes in. So the algebra comes in, sorry. This side x, we don't know the length of that, but if I multiply that by 2.4, so 2.4 times x, if I multiply x by 2.4, that has to equal x add 7. Now you need to think about that statement for a moment, okay? Because what I'm saying to you is that this side here, if I knew the length of that side there, I would simply multiply by 2.4, and that would tell me how long this side is here on the same side on the triangle, because that's how similarity works, right? Okay, that's kind of like how it works. So what I'm saying is that 2.4 times x has to equal the x plus 7 side. But what we have here is an equation, and equations can be solved. So what we've done is we've made an equation. So 2.4 times x has to equal x add 7. Now what I'm going to do, just to make it easier to solve this equation, where it says x add 7, I'm just going to put that that's 1x add 7. Okay, now you know how to solve these simple equations. All we need to do is work out what x is, and you've been doing that since year 7. So how do you solve a simple equation like this? Well, it's 2.4 lots of x equals 1x add 7. So what we're going to do is balance this equation. So we're going to take off 1x from both sides of the equation. Okay, so doing that leaves us with the following. So that leaves us with 1.4x equals 7. Now think about this in a logical way. You've got 2.4 x's, you've just taken away a 1x, so that leaves you with 1.4. And then, right, how do you solve this equation? Well, it's simple really, you just take 7 and divide it by 1.4. Because remember, 1.4 is multiplying x, so the opposite of multiplying is dividing. So all we need to do is 7 divided by 1.4, and that equals 5. So this side here must equal 5. Now, I'm going to have to apologize because this triangle is not drawn to scale. It's not right. It's just completely wrong. But that is what the answer is. So this side must be 5 because we've just worked out that x is equal to 5. Sorry, 7 divided by 1.4 is 5. Okay, so I hope that makes sense to you, and I hope you kind of get that here. There's a bit of algebra involved. That's probably like a harder type problem when it comes to like these scale factor questions. But you have to make this equation here because we've got too many unknowns. Okay, now I hope you kind of understand the steps involved in that. And by the way, that side's 5, but this side would be 12, wouldn't it? Because it's 5 add 7, so that's 12. And you can see that 12 divided by 5, lo and behold, 12 divided by 5 gives you 2.4, which is the same scale factor, because that would have to be true. Okay, so now it's probably a good time for you to have a go at one of these here. Remember, exercise 29 is the easy one, exercise 30 is the harder one. And by the way, if you want a real challenge, okay, that was a bit patronizing, but if you want a super tough challenge, Here's a proof question. It's quite a famous question. You've got these three squares joined together like this in a row, and you have to prove, and by the way, you can make the squares any size you want, so you can make them all 1 centimeter by 1 centimeter for argument's sake, so you can make them all 1 centimeter or 5 centimeters or X centimeters, or whatever you want, but you have to prove the following, and this is really good proof. So these three squares are joined together, and this corner to this corner makes this angle X, and this corner to the top, same top corner, this angle is Y, and then this corner to this corner is Z. Okay, see if you can prove, and what I mean by proof is like giving some sort of logical argument. And it is really cool, but X plus Y actually equals Z in this question here, remarkably. And see if you can prove why that is. Why is it that this angle here plus this angle is equal to that angle there? It's really cool. And you can do it with similarity and a bit of Pythagoras. Okay, thank you for watching, and if you get stuck on this exercise, please tell me, and we'll try and get like a Zoom lesson going or something like that, or I'll make another video, or I'll post the answer to some problem that you got stuck on. Okay, thank you very much, guys.